Greetings. This video is for Calc 2, Volumes by Revolution, sometimes called Revolutions of Solid. And this covers chapter 6.2 and 6.3 in your textbook, but we're specifically going to talk about the shell method, which is mostly found in 6.3. So for shell, if we're going to use the shell method, if L is the line of rotation and L, the line of rotation, is about the x equals a number, then we use dx. L is about y equals a number, then we use dy. So for shell, if x is about y equals a number, we use dy. The same. Y equals a number, we use dy. X equals a number, we use the same, dx. Sometimes you can remember this by shell rhymes with parallel. So we integrate parallel to the line of rotation. Remember that the x-axis is another way to say y equals 0. So if we are rotating around the x-axis and we're using the shell method, that's y equals 0, so we're going to do dy. dy, because y equals 0 goes to dy in the shell method. If we are rotating about the y-axis is x is equal to 0. In the shell method, we would use dx. The y-axis is x equals 0, so use dx in the shell method. This is for shell. Remember, for the disk method, it's opposite. Shell method, it's parallel, so it's the same. So, now this notation is a little bit different than you're going to see in your book, but this is how I like to think about it. I think this is a little bit more of an advanced way to handle these problems, but it's also, I think, much easier to understand. If we're going about x equals a number, then we're going to integrate with respect to x. So we want the height of the function, f of x, and we want the distance from x, the variable x, to the line. But notice I've written this absolute value. So once again, the absolute value from x to L is exactly the same as the absolute value from L to x. Absolute value is the same. The distance from 5 to 3 on a number line is exactly the same as from 3 to 5 on a number line. So I use this absolute value. When I do that, I don't have to worry about should I do x minus L or should I do L minus x. It's a distance. So I put an absolute value symbol. When we were using the disk method, we didn't worry about it because we squared it. Here we don't square it. So we have to use an absolute value. And then we'll just integrate with the absolute value. And I'll remind you how to do that. It's not a big deal. So absolute value of x minus L, if we're doing respect to x. We multiply the whole thing by 2 pi, and we find the bounds of integration in the direction of x. If we're going to use dy about y equals a number, so if it's dy, it's about y equals a number for the shell method. We do the height, which is a function with respect to y. Then we're doing the absolute value from y to L. So y, the variable y, minus L, the line we're rotating it about. Take its absolute value. Then we multiply the whole thing by 2 pi, and we do bounds of integration from a to b with respect to y. Okay, let's look at an example. So we have a region that's bounded by x times y equals 1, x is equal to 0, y is equal to 1, and y is equal to 3, and we're rotating it about the x-axis. So I'm going to pretend for a second that I don't know what section of the book this is from, and I haven't been told if I'm supposed to use disk or shell. So the first thing I'm always going to do is draw a picture. When I draw a picture, x and y, I have to solve xy equals 1 for y in order to draw a picture. So I'm not very good at drawing things the other way around, right? We're used to doing things as a function of x. Well, this is what y equals 1 over x looks like-ish in the positive coordinate. There's also one over here in the negative coordinate. Then we have x is equal to 0, so I'm going to do that in a different color. So x is equal to 0 is the same thing as the y-axis, so this is one of our bounds. This is x is equal to 0. And y is equal to 1, maybe here. And y is equal to 3 is here. So the region I think we're talking about is right here. That's the region we're talking about. So I'm going to color that in. And that's being rotated around by the x-axis. So remember, the x-axis is y is equal to 0. And this is where we're rotating it about. Y equals 0. So about y equals 0. Okay? Now some students find it helpful to cross out x-axis and write y equals 0. To remember those, should I do dx or dy with disk method or shell method, remember x-axis means y equals 0. Okay, so I have a picture drawn. So, figure out the bounds. Sometimes they tell us. Well, they told us here, right? They told us what the bounds were. They said the bounds were x equals 0, that's this one, and y equals 1, y equals 3. Right, so they told us the bounds. So, not a lot to do there. They told us. Sometimes we have to do some algebra to figure out where the bounds are at, where the function closes off on itself or as an intersection with another function. But not in this case, because they told us what the bounds were. So they told us. Number 3, figure out if we are going to use disk or shell. So in this case, I'm pretending I don't know if I'm supposed to use disk or I'm supposed to use shell. So here's how I figure that out. I always start with disk. I just start with disk because I learned that one first, I think. So disk, I ask myself if it's about y equals 0. That's what we're doing, right? About y equals 0. Then I'm going to do dx. Okay, if it's disk, I'm going to use dx. So can I write this thing as function? So as a function, f of x. Can I find that? Well, the answer to that is yes, I could. No problem, right? I can solve that. It would be y equals 1 over x. I've already done that. But can I find the bounds in terms of x? Well, when I look at my picture, one of the bounds is there. That one's no problem. X is equal to 0. That would easily be a bound. But where do I put my other bound? Where is this one at? See how it's changing in here? The bound is changing. So not easy to find that bound. So the answer is no, not easy. So the answer to either one of those questions, can I write the function with respect to how I want to do it with disk? Yes or no? If yes, move on to the bounds. Can I find the bounds very easily? If the answer is yes, then use disk. If the answer to either one of those questions is no, then use shell. Use shell. So, when I use shell, y equals 0, about y equals 0, then I'm going to do dy. So, what is the function with respect to y? Well, that's x is equal to 1 over y. No problem. I took this, solved it for x. I get x is equal to 1 over y. I can do that. I can write a function in terms of y. And then the bounds are easy, right? So the bounds are from, well, in terms of y, from 1 to 3. Very easy. Told us. From 1 to 3. So if we're going to use shell, then number 4, I find this this y minus L, take its absolute value. So y minus L, where L is the rotation, take its absolute value, would be y minus 0. Because we're rotating it around y equals 0. L is equal to 0. So now I have to do the absolute value function. Remember, the absolute value of y minus 0 would be y if y is bigger or equal to 0, and minus y if y was less than 0. So in this case, we are doing from 1 to 3. So y is bigger or equal to 0. That's the case we're in. So we use y. If we were doing less than 0, we would use minus y. So now all we need to do is set up the integral and solve. So I integrate from 1 to 3, put a 2 pi out front. I got my 1 to 3 from the bounds with respect to y. I got the 2 pi because that's the formula. Then I have absolute value of y minus L. But since we're going to go from 1 to 3, I use the positive case. So I use y. And then now I just need to multiply times the function with y's in it, right? So x as a function of y, or f of y. So that's 1 over y, and then dy. So that is equal to 2 pi integral from 1 to 3, and then dy, because y times 1 over y simplified out. And when I integrate that, that's easy to do. I got 4 times pi. Let's look at one more example. In this case, we have a region bounded by y equals 4x minus x squared, y equals 3, and we're going to rotate that about x is equal to 1. So the first thing I always do is draw a picture. So x and y. Then I need to draw y equals 4x minus x squared. So that's going to look something like this. It's a parabola that opens down. And y equals 3. So I have to kind of think about this a second. So if I plug in 3, is that going to be above or below my y equals 4x minus x squared? I certainly can graph it, but from experience, I think it's going to be here, y equals 3. So this is y equals 4x minus x squared, and this is y equals 3. So there are 2 places that that gets bounded off by. And then we're going to rotate about x is equal to 1. So when x is equal to 1, y would be equal to 3, right? So if I plugged in x is equal to 1 into this equation, I'd have 4 times 1 minus 1, which is 3. And the only reason I'm doing that is I'm trying to understand from a picture perspective where to put this line in the right spot. So this is x is equal to 1. And this is how we're going to rotate. So the shape is this shape. And that shape is going to rotate around x is equal to 1. Okay, so what I need to do then is figure out step number 2 is figure out the bounds, right? They didn't tell us the bounds here, but I need to figure them out. So part 2 is to figure out the bounds. So that is where y equals y. That's where y equals y, right? So y equals y is 3 equals 4x minus x squared. So I can solve that. That would be x squared minus 4x plus 3 equals 0. So I need to factor that. So what two numbers, when I multiply them together, give me 3, but when I add them together, give me -4. So -3 and -1 will work. So that tells me that x is equal to 1 or x is equal to 3. So when I fill this out, this spot would be x is equal to 1, y is equal to 3. And this spot would be x is equal to 3, y is equal to 3. That would be those two spots. Okay, now the next thing I'm going to do is figure out if we can use disk or shell. Okay? So if I use disk, I am about x is equal to 1. So if I'm using that, I'm going to use dy. I was given y is equal to 4x minus x squared. So I was given y is equal to 4x minus x squared. So I would have to solve this thing for x and have a function of just y. So that's not possible. Not possible to solve for x. So the answer to that is no. So because the answer to that is no, I'm going to use shell. So in the shell, about x equals 1 means I'm going to use dx. So do I have things I need with respect to x? Yes, I do. Can I figure out my bounds with respect to x? Well, yes, I can. All right. So step number 4 is going to be take x minus L and take the absolute value. So in this case, the absolute value of x minus 1. So the variable x minus the about line, so 1. So x minus 1, take the absolute value. So that is x minus 1 if x is bigger than or equal to 1, and it's minus x minus 1 if x is less than 1. Well, where is my x? X is, well, in this case, x is from 1 to 3. So 1 to 3. So since x is bigger, we're going to use bigger than 1 or equal. We're going to use that one. And we have use x minus 1. So step 5, set up the integral. Put 2 pi from 1 to 3. And then x minus 1. And now we have to multiply by the height. So be careful about this height. What is the height of the thing we're looking at? Well, it's 4x minus x squared. And then minus away 3. So the height from the origin would be all the way up to 4x minus x squared. But we are just wanting this part up here. So the height of that function with just this part up here is 4x minus x squared minus away 3. So we're minusing away this part, and it leaves us with just what's up top. So 4x minus x squared minus away 3 is our height. 4x minus x squared minus away 3 is my height, and then dx. And when I evaluated that, I got pi times 8 over 3.